everyone, and a warm welcome back to Directions Live Online. My name is Sharon Jin, and I'm a manager with ASHRI Singapore, manager of the Solution Consulting team here at ASHRI Singapore, and I'm going to be your host for today's webinar session. So the topic for our webinar today is on digital twin, the fundamentals of digital twin. Right, and in summary, we're going to talk a little bit about the different aspects and the components to consider when you're trying to build your own digital twin, and what are the different forms that a digital twin can take. And of course, most importantly, how a digital twin is going to be useful for your day-to-day operations and also your workflows. And with us today, we have two solution consultants from ASHRI Singapore. First up, we have Kai Ying, and she comes with international experience in city planning and a background in urban design and GIS. And we also have Kam Cheong, we call him Casey by short, whose passion is in working with agencies to build their geospatial roadmap and in deriving organizational success through innovative technical solutions and meticulous planning. And with that, let me hand the time over to Casey.
Hi everyone, thanks Sharon. Thanks everybody for joining us on this cloudy Thursday afternoon. So I guess most of you are interested and have a keen interest in looking at how you should actually embark on a digital twin journey. So today we will be actually dwelling into how a digital twin can actually help you from a geospatial perspective. So next, probably I'll jump into some of the agenda items. So we'll be covering some of the framework which guides clients on how they should actually embark on this journey. What are the considerations of starting a digital twin? Next part, I will hand over to my colleague Kai Ying. She will be covering applications of the digital twin. And to wrap up, we have the benefits and as well as Q&A session. So do keep your questions in mind and post it at the end of our session. So before we start, I'd like to take a step back and to actually look at our reality before the life of a digital twin. So what you see here is actually a CAD file. So this might be your role, handling CAD files daily, or it could be looking at external data sources, for example, textual information, Excel data sets, IFC files, or 3D models. And most of the time, we are actually working with multiple applications for different files, or probably coming from different systems. So the complication arises when we try to make sense of all these data sets among a common area. So today in our sharing, we are here to help you in your digital twin journey. So most of the data that you work on should actually fall into one of these category that you see here, starting from the left, what we call a land-based information model, a LIM. Mostly it consists of environment information, social data, or probably some of the landscapes layers as well. Moving to the right, BIM, building information model. It really provides you an accurate and detailed representations of your structures, plants, and facilities. It could be bin files or CAD files that you're working with, and it has a 3D digital representation in your daily work. And the NIM, Network Information Model, it typically manages the design and logic for networks, for example, in the utilities network, how they manage all the connectivity across the assets. So lastly, also the City Information Model, CIM, allows for bigger picture modeling at scale. The scenarios or users base you see here are more of citizen engagement. As Singapore moves towards a smart city, smart communities, so these are the areas where we see a lot of users and data sets connected. So underlying all these are actually capabilities or data sets which a GIS platform can support. So it's mainly used for a common operating platform to support these various working models, as you see. So what exactly is the relationship between digital twin and GIS? I think it's key that we start off on the right track. So GIS is actually the supporting platform which helps to create a digital twin where it brings in all the various information models which we've seen earlier on, More importantly, it could be in 2D and 3D as well. In your organization, a simple 2D map of your assets around the island could be a digital twin, and it really depends on where your organization actually starts. It's always important to have some guiding framework. I think both based on our experience, it helps organizations plan for their digital journey. So what you see here are actually processes that organization takes to achieve a digital twin. I can consolidate them under a few categories: data, integration, and visualization. So for data, we are looking at how this data can be actually collected and integrated. For example, taking in some of the BIM files, how this BIM file can be transformed and stored within a digital twin platform. Moving forward is looking at how the data 3D models can be brought in. More importantly, you want to make useful decisions out of the systems. So what are some of the analytics that you can actually bring in? More than often, we start to see key users asking for a visualization platform. So what are these applications, or what are the use cases that you are actually going to meet? So this is some of the considerations we will be sharing later on as well. Last two processes are how the integration is going to happen between physical systems. For example, as you move into a complicated digital twin, it could be integration with existing building management systems, where you can actually visualize this information on dashboard. Lastly, we see a key request from agencies with citizen engagement requirements dwelling into some of the AR and also VR requirements. Now, something to take note is that as you delve deeper, as you step up, the complexity and data requirements increases. So I think it is key to have a single platform with the capability to integrate your external data or systems as well. So integrated digital twins is really all about just interconnecting the content, behavior, and workflows. So what do I mean by that? Starting from the left, you start to see the different teams of your planning. For example, urban planning, smart cities, resources planning. These are the teams that organizations are working on, and how do they actually integrate into the various information models, workflows, to meet actually key outcomes that the organization needs or requires. So this is how we actually visualize the integrated digital twin that we have envisioned. More importantly, in your organization, you might be looking at various different type of data sources. How can all these various information be meshed, brought into the supporting platform or geospatial platform, supporting your digital twin needs? For example, we have the ability to extract information from point clouds. If you have existing BIM data, we definitely can bring it into our platform and mesh these different data sources together. Lastly, we would like to mention that there's also a partnership with Autodesk. So we have the ability to work with Autodesk Cloud, where you have the BIM files actually stored within the platform, and our software can actually work with that as well. After bringing in a model, I think there's definitely a need to visualize this information, how you can actually visualize this data. Just to bring your attention to the interactive slides. So if you have a BIM model shared to the web, there's capability for you to slice and dice through the BIM model to look at the fundamentally underlying structural, mechanical pipings and so forth. Of course, as the data gets updated, the file will also be updated. So you can actually visualize this information on the web. So I think this is interesting for most of our clients as well. The analysis phase, where we start to make sense of the information coming in, be it a collection of imagery to process, to make into 3D objects meshes. This is some of the tools and workflows that users have been looking at. As I mentioned, as you start to integrate with more physical systems, you'll start to have a lot of data being consolidated. So there's really a need to make sense of this information as well. You might also need a platform to run some of the big data analytics. One of the example is using Jupyter Notebooks to run some of the Python scripts available and start to make sense of your data within a single common platform. I think maintaining the value of a digital twin requires ongoing investment in people and process. I think this statement brings out the key considerations of people and processes that organizations need to ponder on before most of us actually jump into a digital twin. So we consolidate some of the key considerations: people, process, technology. These are just some key questions that you might want to make a checklist out of or have it at the back of your mind to ponder upon. I think first is to identify the stakeholders. Stakeholders meaning it could come in various forms, recipients of the information, who are your end users, who are the data contributors, for example, who will be actually providing this information or data to you, managers and operators. Secondly, the skill sets required from each individual organization differs based on your digital twin strategy, which brings me to the next point of what is the long-term organization strategy for your business. Would it be more citizens focused or operational focused? Because this will determine the purpose of the digital twin. Is it informative? Is it a decision-making systems? And this will actually definitely drive or impact your business processes, because coming in from how will this digital twin platform, digital twin technology affect or change your existing business processes. For example, if you're doing a general tasking, you might be looking at a 2D postal code address or lat long. You might be directing your assets towards that location. But with a digital twin platform, you might need to consider the height element. So definitely there will be some impact to the existing business processes. I think this is also a key considerations for you to look at. I think last pointer on the technology portions, before we start or jump into digital twin, we need to do probably a checklist of what are the data sets available. If we are looking at a real 3D digital twin, do we have or are we able to source or produce some of the 3D data sets from our existing data? Considerations also come in the forms of how will the data be updated. It will cost an amount of money to actually fly some drones or fly some aircraft to collect imagery, generate 3D models. So this is a condition that you might need to take into account when you're looking at digital twin. And last, it will be the security and privacy issues of the data sets. How would it be managed based on different roles, data ownership, data stewards? How would this be impacting or managed within the key platform? So these are just some of the key considerations that we brought to the table for you to ponder upon.
So now that we've covered the fundamentals of a digital twin and what it takes to create one, let's move on to how these digital twins can be used to help you in your work. As Casey mentioned, when considering starting on your digital twin journey, how it takes form will really depend on a variety of factors, and the possibilities are really endless, and what I'm showing today is certainly not exhaustive. But I really hope that today you see something relevant to you that will spark an idea for your organization. So here are a few high-level outcome-driven approaches that digital twins would usually fall into. An environmental digital twin can visualize and analyze how environmental indicators might impact ecosystems and subsequently future plans and projects. A network digital twin provides utility companies with the ability to model a network and its relationship to components, allowing for flow analysis. A design or construction digital twin can support querying of assets in context, see project status or issues on a map to make more informed analysis and decisions. A planning digital twin allows planners to explore different scenarios and identify which one addresses planning criteria like accessibility and zoning metrics. And lastly, an operations digital twin provides a cohesive overview of assets or maintenance activities, even in real time. And if you already have or have taken the steps to create a 2D and 3D digital twin, but you want to take it further to really reflect reality, there's also capability to use aerial or terrestrial imagery to perform reality mapping. So I'm going to dive deeper into each of these use cases I just talked about. So for an environmental digital twin, you would probably provide scientists, conservationists, landscape planners with indicators on environmental risk and how it might impact biodiversity, future plans, and projects. For example, in the bottom right, we have Esri's drought-aware map that displays statistics and impacts of drought in the US. This information can then be used to observe, predict, and plan for agricultural, biodiversity, and socioeconomic impacts. The other examples display species biodiversity and connectivity, which is important for conservation, and a green infrastructure asset finder, which can help identify areas lacking green infrastructure to address sustainability goals. And I'm just going to show an example of a digital twin in action. So I'm going to talk about the city of Carlsbad. So to protect water quality, the city was required to install treatment control structures to prevent pollutants from entering their waterways. The city needed a way to maintain an inventory of these structures, including inspection, maintenance, and follow-up actions. And they did this by creating a digital twin of these environmental structures that they could use for operations and maintenance. That's where they developed the automation, compliance, tracking, inspection, and owner notification system, otherwise known as ACTION. The ACTION system creates in real time a big picture perspective of green infrastructure compliance using geospatial analysis that enables the city to then prioritize sites, schedule inspections, evaluate problem areas, monitor inspection results, and review maintenance records throughout the city's network of green infrastructure. This digital twin that you see is a simple yet very comprehensive data management platform that improves their data tracking and collection for annual reports and audits. It also increases the city's ability to respond to public inquiries, reduces paper documentation and storage or filing. It streamlines the compliance tracking process and creates better situational awareness between inspectors, green infrastructure owners, and other stakeholders. So a network digital twin would provide utility companies with a model of systems such as electric, gas, telecommunications, and water. It also includes all the components within the system, such as wires, pipes, and valves. But really, more importantly, a network twin is more than just the graphical representation you see on the maps here. It doesn't just represent features, but also the relationships, rules, connectivity between the different types of assets. And because of this, we're also able to model or analyze directional flow. We can perform analysis to trace how resources like water or gas would flow through the network, which is especially helpful during events that may cause disruption. So here we have the city of Hastings. They wanted to provide employees with analytic data for project planning, replacement programs, and inspections. But all of this would require eliminating their current paper-based workflows, which involved using a combination of CAD, paper forms, and Excel, which is the reality that Casey showed earlier. And it also required them to then move all of that to digital data collection in the field so that updates are instantaneous and viewable by staff on a daily basis, which before they performed this digital twin transformation, it would take them months for the data updates to be reflected digitally. But by creating two network digital twins, so one for water and one for sewer utilities, city employees can now view up-to-date, high level of detail data both in the office and the field. What used to take employees days to sift through dated drawings and Excel spreadsheets can now be easily filtered through GIS, giving them greater resources for project planning and replacement programs. And by using field surveys linked to the digital twin, this improves updated information to all employees instantly via web maps, and instead of taking months to get updates via handwritten forms and maps from the field to GIS. They also use these two digital twins to generate dashboard reports for supervisors to help identify any patterns or problem areas. And I thought that this is a really great example to share with you today for why digital twins can take our reality of disparate data sources and create an integrated platform to easily view your data. So the planning twin is designed for urban planners and designers. It streamlines a performance-based planning framework that allows planners to create, evaluate, and present scenarios to all on one platform. For example, on the left with scenario planning, planners can create massing studies by applying regulation and policies like land use and zoning code, which will help them evaluate the impact of potential developments in an area or site. Then to further develop the plan with realistic 3D visualization, urban designers can apply computer-generated architecture or CGA rules to generate more realistic 3D design with building facades, streetscapes, and landscapes. And lastly, designers can take the design and create immersive walkthroughs of the plan. This step will generate animations and experiences that can transport us to the future of a city, a neighborhood, or a building. So just to demonstrate the scenario planning, by having a planning twin, planners can create or make zoning changes and propose different development scenarios to accommodate growth. For example, evaluating a plan's disaster risk by viewing flood zones, tsunami evacuation areas, and evacuation shelters. We can use a suitability model to score the parcels where a lower score means it faces higher risk based on these data layers that have been brought into the planning twin. The suitability model can be just one variable, but you can just as easily add other weighted variables and see how that affects the scoring. And if the result shows a parcel that's not suitable for development due to high risk, we can create a new scenario where instead of heavy residential and commercial buildings, we add more open space. And given the metrics set up, the number of trees and area of open space can be automatically calculated and compared to the original scenario. All of these changes can then be communicated to the team through pin drops and comments. And so a planning twin is really great to streamline the scenario planning and design process based on defined strategies. A design or construction digital twin can support querying of assets in context, see project status or issues on a map to make more informed analysis and decisions. With BIM data available, this kind of digital twin is most useful when in 3D. And with our tools today, we can bring BIM models into GIS and overlay additional context data, as well as real-time sensors, or even time-enabled 3D meshes generated from 360 images that will show how construction changes over time. Documents from Autodesk can also be piped into the digital twin through our partnership with them, removing the need to switch between applications. And by integrating BIM and CAD data into GIS, we can build collaborative web apps that not only visualize the data, but also help stakeholders understand project status and insights through 3D maps and dashboards. We can also link documents like DWGs and view them in a fully functional 3D viewer to go through BIM models or drawings from the source BIM 360 project. For example, by integrating BIM models into a construction twin, you can view BIM models with contextual data and view charts. The BIM models of the approved building can also be uploaded and symbolized with different colors to represent the different stages of construction progress. In this example, the blue means completed, red means work in progress, and gray means pending. This not only allows all stakeholders to be updated on the latest construction progress, but also be able to visualize the end outcome of the construction project. So having a design and construction twin that integrates BIM and GIS can reduce data exchange gaps and duplicate efforts by reducing data silos and inform efficient decision-making. And lastly, an operations digital twin seeks to provide industries with optimization, improving product or service quality, and predictive maintenance. To support that goal, IoT integration for operational digital twins can provide a dynamic virtual representation of what's happening on the ground in real time. If that data is stored, organizations can also use it to perform analysis and understand historical trends to perform predictive analysis that will influence how traffic, assets, or maintenance can be managed more efficiently. And the last case study I wanted to share is the San Francisco International Airport, where they've used GIS to create a 2D and 3D data asset inventory for operational efficiency. Initially, SFO largely used 3D BIM models and CAD files for operations, but they had no spatial data, which caused gaps in communication between the maintenance and ops teams. They recognized their need for a digital twin that would serve as an asset inventory in 2D and 3D to map out things like utilities, buildings, planes, runways, and even airfield lights. And I've put these other digital twin icons here because although the purpose was for an operations twin, in order to achieve that, they needed to build a whole digital twin ecosystem that includes other types like a design and construction twin and a network twin. So what you see here are examples for how they use their asset inventory for operations. The left shows how their BIM data for one specific area can be seamlessly integrated with their 3D GIS dataset. The top right is a 2D subsurface utilities infrastructure viewer that utilizes a network twin, and the bottom right shows all of their assets in the airfield. The digital twin doesn't have to just serve assets outside, but SFO also wanted to monitor and maintain assets indoors with spatial awareness, such as Wi-Fi access points and AEDs. And as you can see here, a digital twin doesn't have to be in 3D. Sometimes 2D is really enough to fulfill the purpose of the twin. But once you have your 2D digital twin set up, you can always take it further by going to 3D. So just to recap, SFO having such an extensive digital twin ecosystem has really enabled them to have 3D spatial awareness and improved data accuracy of the airport buildings and assets. The BIM and GIS integration enabled operations team to proactively plan their day and respond to more requests per day. It also ensured stock and plan for repairs and replacements. And lastly, with the indoor GIS that you see here, it improved passenger experience with a wayfinding application. To summarize what we've talked about today, here are some of the benefits of digital twins. So first is improved decision-making. Digital twins provide real-time data, allowing for more informed and timely decision-making. And also by simulating different scenarios, digital twins can predict potential issues and outcomes, helping in proactive decision-making. Second is enhanced operational efficiency. Digital twins can optimize operations by identifying inefficiencies and suggesting improvements. Predictive maintenance can be scheduled based on the digital twins data, reducing downtime and extending the lifespan of assets. Third is improved product development. Digital twins allow for virtual testing and simulation of scenarios before deciding which addresses the requirements. They also enable the customization of applications to meet specific customer needs by providing a base data set to work on. We also have enhanced customer experience because a geospatial digital twin can provide the public or communities with a more tangible way of understanding urban plans or the spaces around them. There's also a continuous feedback from the digital twin, which can be used to improve operational efficiency, which then also impacts customer experience. For risk management, digital twins can simulate various risk scenarios and their impacts, helping in better risk management and mitigation strategies. It also ensures compliance with regulations by continuously monitoring and reporting on the scenario's performance. And lastly, sustainability. Monitoring and optimizing energy use can lead to more sustainable and efficient operations. And by optimizing processes and maintenance, digital twins can help in reducing waste and improving overall sustainability. So with ArcGIS, customers can use our whole suite of GIS products to enable data capture and integration, visualization and real-time data, analysis and prediction, and sharing and collaboration for digital twins. You can combine reality capture, BIM, 3D, 2D, planimetric data, and real-time feeds in a dynamic, interactive experience to help describe individual facilities, large utility and transportation systems, and even entire cities. You can explore geospatial digital twins on mobile devices, in a web browser, or through rich desktop applications from Esri and our partners. And finally, you can make the geodatabase portion of a digital twin accessible for exchange and integration with other enterprise systems. So to help you learn more about digital twins and get started on your journey, here's some resources. The first is the Esri page on digital twins, where you can learn more about how digital twins drive innovation across industries. The second is Esri's Learning Tutorial Gallery. I really like to use this gallery because it consists of tutorials for different skill levels, and some of them can be done within 30 minutes, which is really quick. And lastly, if you want to learn more about ArcGIS and digital twins, this link brings you to a page listing out Esri's blog posts that relate to that topic. And with that, I'll pass it back to you, Sharon, to close this off. That's okay, I will jump in and close off and pretend I'm sharing.
I'll jump in. Hi, everyone. Mary
Okay,
here.
thanks, Mary.
There's no problem. Kai-Ying, do you have a question that you want to cover off for the crew before I jump into some additional ones that have come through here?
Yeah, sure. Let me see. Okay, so I guess first question, which actually I'm going to ask myself. How do you bring in a BIM or CAD file?
Very common question.
And yeah, how does our platform support it, and what are other 3D formats that you can work with? So this is a very, as Mary said, a very common question. It's a really good question. So for our desktop product, ArcGIS Pro, it supports files from AutoCAD, which includes like DWG, DXF files, as well as MicroStation, which are DGN files. For BIM files, Pro supports IFC and Revit files. So when I say it supports, it means you can open the files directly into Pro. And then in terms of 3D objects, I'm not going to list all of them, but a few of the common ones are like Collada, so .dae files, DWG IFC, and also OBJ. If you Google ArcGIS Pro 3D object types, you can definitely find a list somewhere on the website. So I guess just one other thing for this question. Of course, in order for Pro to like place the data in the correct spatial location, the files need to have a defined coordinate location. So if you want to have a seamless CAD to GIS workflow, it's always good practice to make sure that your CAD file has the coordinates and spatial reference set. Of course, if not, that's okay as well, since Pro also has tools where you can move your data into the correct location through a process called georeferencing. Yeah, and I'll pass it back to you, Mary.
Yeah, cheers. Again, that's a very common question because there have been a lot of people working with, AutoCAD data for many, many years and bringing it into a GIS. And that process is a lot easier nowadays, especially because the platforms are so integrated, right? Excellent. So another question that has come in here is, I have only data in 2D, how to transform it to a 3D and digital twin? So who wants to take that one? Kaying, Casey? If I have 2D data, how can I work with it?
Okay, I'll take a stab at it. So I think a lot of agencies do have this same scenario where they only have 2D data, but you'd like to move on to a digital twin journey. I think the way that we work with them are actually to identify if there are any height elements, because CAD files do have the ability to actually contain a height or depth element. So for example, if you're looking at utilities or pipelines, you might need to have a depth element for them to be visualized properly. Otherwise, a height or a floor equivalent data could be also used in our platform as well. Yeah.
Yeah, awesome. And that's where a lot of people start, right? Is with the 2D data and, create your models and then move along to 3D. So that is a really common workflow for people to move from using 2D to 3D as well. Awesome. Yeah. Okay, so can we move on to that next slide just while we go through some additional questions that have come through here? Wow, lots of questions. Okay, going to keep you busy for the next few minutes. So the first one that came through is a little bit of I think this is an unusual one, but it's a great one from Vignesh or VP Vignesh. Thank you for the question. Could you please explain the difference between cyber physical system and digital twin? So this might be a little bit outside the scope for you guys, but do one of you want to give it a go?
I think the naming convention is different, but otherwise we are also looking at digital twin, but in a different context. We're looking at the cybersecurity of systems. I think we do have some use cases, but I will not say that we are not fully working on such use cases. But we've seen some examples where they are actually connecting information between the routing IPs. For example, IPs resonates with a location. How do these locations actually join up together? So we are able to present the visualization part of your system, because you might be just brought in with an alert routing from a particular address, but that IP address usually refers to a location. I think this is something common in some of the banking transaction systems as well, where they try to find some fishy businesses out of these huge transactions. Yeah.
Cool. Yeah, we might follow up with some post-event, post-webinar materials on that as well, because it is something that's starting to creep into the conversation. So it's interesting. The next question from NQ, is there a public URL which we can tune in to better appreciate this digital twin? So I think it was probably one of the digital twins that you guys were demoing. And I can see Sharon has actually popped some public links on digital twins into the chat. And I know there are lots of examples of use cases and so on of people building digital twins of various sizes and scales. So I think that's a job for you guys to pop some of those into the chat if you have them there. And if not, let's follow up afterwards with some URLs. Cool. Actually, that was another question, Naif. Same question about sharing the URL for the use cases today. Yeah, so if we can pop those into the chat, that would be
Sounds
great.
good. Yeah.
Yeah, awesome. Another question here, Phoebe. You are keeping us very busy here with your questions. How to integrate different data? Some might be numerical, some might be 3D models. I think this is similar to that 2D, 3D question. But if we want to talk about data integration of different data models, who wants to talk to that one?
So I think
I can maybe. Oh,
yeah.
okay.
Kindly do take the question. Go ahead.
I'll start, but I think Casey will have a lot of things to add on. Because the first thing that came to mind, honestly, is this thing about using CAD data, whereas in GIS, we have a lot of attributes. And so usually what we talk to our clients about is for your CAD data, like if you have a like a polygon or a closed polyline, that closed polyline needs to have like a reference ID. So say it's polygon 1, and then in your Excel, if you have all these other attributes that relate to that polygon, you also need to have the ID related to it. And so then we can bring both CAD and Excel into ArcGIS Pro and join them together, and the output would be one single like geospatial file. Casey, do you have anything to add on?
No, I think you exactly read my mind. I think that's what I wanted to say as well. I think as long as you have a reference that you can tie these attributes to, I think definitely that can be represented in the geospatial platform. Yeah.
Yeah, awesome. The next question is how accurate these twins are. So in terms of location accuracy, because photogrammetry or reality capture or drone data will have different accuracies. That's a really good question. Who wants to talk about that?
I think there are a few levels to, if you want to talk about accuracy. First is the data capturing mechanisms, your imagery resolution, for example. Secondly is the coordinate system. I think within Singapore Survey 21, the coordinate system do mesh up to a certain decimal places. I think these are the few areas that we can actually look at. Most of the time, the issues that we work with our customers are at the data capturing portion, where we explore how we can actually integrate and mesh these various data sources together, which are within the same area. But I think to conclude, those are the two areas that we most likely will be looking at.
Awesome. And again, it's garbage in, garbage out, right? It's about having
Exactly,
data at the best accuracy that you can capture it at, and then knowing what you need it to be at and building your twin accordingly. And then if you do have data that's probably not going to be as accurate as other ones, making sure that you can tell people this is the accuracy that we're working with here, right? Awesome.
Yeah, exactly.
Excellent. Yeah. Next question. To what extent of the Singapore digital twin has that been achieved? Like integrating all twins into one platform, or still all the twins like network land operational or fragmented? So this is, I suppose, that idea of, integrated geospatial infrastructure all going into that one digital twin. Where are we with some of that in Singapore? Who wants to speak to that? I know we've had some good case studies on big stages recently.
So I think okay, probably I'll take it. So it's a good consideration, but I think it is not up to us. We definitely want to have a Singapore digital twin. But the point here is that we do have the platform to support the digital twin. We can drive the capabilities to meet what the digital twin or agencies want. But how is this being drive or represented across the various industries? For example, you can't be having a utility agencies looking at above ground information, because most of the assets will be underground. So that's one of the considerations where we would be glad to work with agencies to see how we can actually mesh up these information to find out, to make more sense and to make more information out of that. So this is where we are heading towards. And if there are other opportunities that you would like to speak to us, I think we are open and we'd like to speak with you as well. Yeah.
Yeah, because there's not a one size fits all digital twin, right? And I know some organizations work together collaboratively to build digital twins and so on. So again, it's not a case of throwing everything into the one digital twin and it'll do everything. You have to design and plan your digital twin. So I suppose, yeah, there's probably multiple Singapore digital twins, but all with different purposes. Yeah, cool. Another question.
Mary,
This is a good one.
Can I just add on a little bit?
Yeah.
Yeah, I think it's also about if one agency has, for example, planning digital twin, so URA, I think what's important is being able to share out that information to other agencies that need it for their work as well. So there might not be like one single platform where all of the data sets are together, but it might also just be being able to share that to those who need it for their respective digital twin use cases.
That's a really good point, right? If it already exists, let's use it, let's share it. Awesome. Next question we have is, what are the challenges you have to overcome while developing developing twins for smart city scale? So I suppose, what are some of the challenges you guys are assisting with people who are building digital twins, or that you have seen?
I can start with this one, especially since I focus on the built environment. A common, I guess, challenge that we come across is the very first step of converting 2D or like CAD data to GIS. I think to make that a bit more, or to make it more seamless, it would help if the CAD files are, each layer is kind of clean. So if it's not in GIS, what we spend a lot of time doing is cleaning up that data so that each layer is, reflecting a specific asset, and also if there are polylines, they're snapped and closed. Otherwise, there is, a big manual process to convert everything to GIS. So for me, that's like the really big challenge, because once you get past that, once you get your data into GIS, really, you can do a lot with it. Yeah.
Yes. So data management, data capture and creation, data engineering, back to the basics. We still have to do the basics well, right?
Yeah, I think it's about really rethinking how business processes should work in an efficient way to support the digital twin as well. I think one of my use cases, I can't remember which one, like I said that they had to go from paper form to digital form. And so that obviously comes with a lot of changes in the workflows.
Yeah, that's a really good point. Yeah, brilliant. Okay, I'm very conscious of time. We do have a couple more questions that have come through, but what I'll do is I'll pass them to the team and we'll follow up on all of them afterwards as well. So that is all the time we have for today. So thank you everyone for staying with us, for enjoying the session, and for those questions. And thank you, Kai-Ying and Casey as well. So before we leave you, let's have a look at some of the upcoming sessions that we're going to have over the next little while. So a little bit of a sneak peek. We're going to be covering oriented imagery, we're going to be covering something called ArcGIS Knowledge, and we're going to be looking at ArcGIS Video Server, and a lot more over the next coming months. So make sure that you subscribe to get notified as to when those registrations open. And when we wrap up today's session, you'll also see a survey pop up. The team love getting your feedback, any final questions you have, any final comments. We always think of something afterwards. So please take the time to fill out that brief survey. I think it's like 5 questions. And if you would like to re-watch this webinar or share it with your colleagues, the recording will be shortly available on the Esri Singapore webinar page. One final thank you again to Kai-Ying and Casey for putting all that effort in, talking to us. We'd be here all day talking about digital twins. But for now, thank you all, and we look forward to seeing you again soon for another Directions Live Online.